Assalamualaikum and good afternoon everyone. How are you today?
Waalaikumsalam, teacher. Good.
I'm fine.
Okay, did you already have lunch yet?
Not yet, teacher.
No. For the student I have lunch, you can do so after our class, okay?
Okay, teacher.
Okay, good. So today we are going to learn about limits and its relation to differentiation, which is the first subtopic under the topic of differentiation. But first, let me explain about the learning outcome of this subtopic so that you can expect what you are going to achieve from the lesson. Okay, at the end of this chapter, students should be able to investigate and determine the value of limit of a function when its variable approaches zero. And then, students should be able to determine the first derivative of a function fs by using the first principle. Okay, so class, are you clear with that?
Yes, teacher.
Yes, teacher.
Okay, good. So let's proceed with our lesson today. But before that, I will give you an example of a situation so that it will give you a clear picture about what we are going to learn in this subtopic. Imagine that you are riding in your car right now. So what do you think about the speed of the car?
The speed changes.
Yes, the speed of changing, right? This is because the car is moving with the non-uniform motion and it is not constant. Whereas if you compare with the speed of when you are riding in a train, the speed will always be constant. Am I right?
Yes.
Yes.
Okay, good. So when the speed is not constant, what do you think about the graph that we get in order to represent? Right?
Teacher, can you repeat again?
Teacher,
Okay.
can you repeat again?
Okay. So, when the speed is not constant, so what do you think about the graph that we will get in order to represent the speed of the car? Are you clear?
Curve graph.
Maybe it's a curve.
Yes, we will get a curve graph because it is non-uniform motion. So here is the graph. Okay. Right now, we are discussing about the speed, right? So student, what is the formula for the speed?
Distance over
over
time.
Distance over time.
Yes, speed is equal to distance divided by time. Okay. However, what if we want to know the speed of the car at the particular time from a curve graph? If we have a linear graph, because we are able to find the slope of any point on the straight line graph. However, for the curve graph, we cannot simply do that. We will not able to find the exact slope at a single point on the curve. So the best way that we can do is we need to find the average rate of changes for the particular point. Okay, therefore, to do so, we need to apply the definition of first principle of differentiation. Okay, here is the formula for the first principle of differentiation, which is dy over ds equal to limit h approach to 0 f function of x plus h minus b minus weight function of x and divided by h. Okay, but first, let's get to know about the detail about the formula. Okay, plus, what is dy over dx? Sorry.
Slope.
Slope.
Yes, it is equation of the slope and also known as f prime s, which is defined as the derivative of x with respect to x. And then from this derivative, we will get the tangent line that will be used to find the rate of changes for a particular point. Okay. Sorry. Okay, next. What is H? Anyone?
Is it interval value, teacher?
Yes, correct. H is the interval value of secant, which can be referred as delta S. Since in order to get the value of H, we will calculate the value of changes in S, right? So the change in S equal to S1 minus S0. Okay, then what about the limit? And why there is H equals to 0? Anyone know about
I'm
this?
not sure, teacher.
I don't know.
I don't know, teacher.
It's okay, I will explain it for you. Okay, basically, this symbol shows that we can use limit as the interval approaches to 0, which is in order to make the interval as close as possible to 0, but without actually becoming 0. It means that to get the most accurate value of the speed at a particular point, the smallest number of interval value. I know it's quite complicated, right? But don't worry, you will understand this concept when we go through the example after this. Okay. All right, so here is the example on how to understand the concept of limit h approaches to 0. Okay, let's say we want to find the speed of the car at the particular time, which is 10 seconds. It will be at point F, right?
Yes.
Yes.
Okay, but remember, because it is we cannot find the exact slope at that point. So we need to find what class?
The average rate
Interval
of
value.
change.
Yes, the average rate of change. Okay, here we have so many points on the curve. But to get the most accurate value, we need to identify the point that have the closest secant to the point F. Okay, to identify the closest one, we need to calculate and compare the value of H. Okay, class, what is H? You still remember, right? What is
Interval
H?
value.
Value.
Yes, correct, the interval value. Okay, for example, here we will compare the interval value between the two secant, which is EF and DF. Okay. Okay, the EF is in the orange color, and DF is in the pink color. Okay. So we need to calculate the value of H for each secant. Okay, for EF, H is equal to S1 minus S0. Okay, this is S1. Oh, sorry. This is S1 and this is S0. Okay, what the value of S1 class?
10.
10.
10.
And minus with S0, which is
8.
8. Okay, and then we will get
2.
2.
2. Yes. Okay, for the value of H for the EF is 2. Okay, next. For the value EF, what is S0? What is S1?
10.
10. Okay, S0 is
6.
6. And then when we minus 10 with 6, we will get
4.
4.
4. Okay, good. Okay, so we already can see which can to the point F, right? So which secant the closest class? Which one is the
Secant
closest?
EF.
Okay, yes, EF.
EF.
But why do you think it is EF?
Because the H is smaller.
Yes, excellent. Because it has the smallest value of H. So that is the meaning by the limit approaches to zero, because in the calculation of average rate of change, we are considering the nearest secant of the slope to the particular point in order to get value. Okay, so let's proceed with the question that we are going to apply the definition of differentiation. Okay, the question is, okay, find the speed of the car when t is equal to 10 seconds by using the definition of differentiation for function of t equal to t squared. Okay, first of all, to keep us always in our track, let's write the formula, okay? So class, what is our formula for the differentiation, the definition of the first principle of differentiation?
F prime t equal to limit h approach to 0 f 3 t plus h minus function of t divided by h.
Okay, good, Hafiza. So this is our formula. So bear in mind, because we are going to use this formula in our calculation. Okay, next, we need to define our function of the graph. Okay, before this is our diagram, right? So what is the function of our graph?
T square.
T square.
T square.
Yes, correct. Our function of the graph is t squared. Okay, next, we need to substitute the value of t plus h in the function of t plus h. Okay, in this one, we already get the function of t, which is t squared. Okay, how about the function of t plus h? We just substitute the value in this equation.
T plus H
T
square.
plus h square.
Okay, good. We will get t plus h squared. Okay, this is our information that we will need in our calculation, okay? So next, we need to substitute all the value into the formula. Plus, what is the value for our function t plus h?
T square
T square.
plus
T plus h square.
Okay, good. T plus h square. And our value of function of t is
T
T
square.
square.
t square. Okay. So all we need is substitute the value that we get in our formula, and the um, uh, this is the answer that we get after we substitute our value. Okay. Okay, for the t plus h square, we need to expand. So what will we get when we expand this equation?
T squared
T
plus
square.
2th plus h squared.
Okay, good. We will get this h plus h square, and don't forget to minus t square. Okay, let's solve this problem. Okay, what we can do is we have t square, right? And we have minus t square. So when when t square minus with t square, we will get
0.
0.
0. So when we cancel out, we will get 2h plus h square over h. Okay, class. For this one, we need to separate the equation, and we will get 2 multi h over h square over h. Okay, so from this, what we need to do, class?
Cancel
Ensure
out
that you
Cancel H.
Okay, correct. We need to cancel h. So when we cancel on h, this one 2th over by h, when we cancel, we will get
2t.
2t.
And then for this one, h square over by h, when we cancel h, we will get
H.
H.
h. Okay, so our answer is limit h equal to 0, which is 2t plus h. Okay, and then since we are learning about the limit h equal to 0, so the value of h we can substitute with the 0 because it is equal to 0, right? So we will get 0, we will get 2t. And then, okay, from the question, we need to find the speed of the car when t is 10 seconds. So what we need to do is substitute the value of t with 10. So the function, the f prime of 10, we will get what class?
20.
20
20. Yes.
20 meter per second.
Okay, correct. All we need to do is we just substitute the value of 10 in our t. So we will get 2 times 10 and equal to 20 minutes per second. 20 meter per
20
second.
meter.
Okay, sorry. Good Nadira. Okay, for the conclusion, wait a minute. Okay, for the conclusion, can I have someone to answer this? What is the formula of first principle of differentiation?
Teacher, I want to answer.
Yes, you.
uh, the formula of first principle of differentiation is we find the dy dx. So
Mm-hmm.
the formula of limit h approaching 0 f
Mm-hmm.
x plus h minus fx over h.
Okay, good. 5 star for you, Amira. Okay. Okay, next. Okay. What is the function of first principle of differentiation? We already know the formula. So, what the use of the formula?
To
The
find the
answer, teacher.
slope.
Oh
Ah,
no.
I
It's
answer
okay.
first.
Who want to answer? Okay. Okay, Hafiza.
Okay, so the first function is we can find the slope of tangent.
Okay, and then
I forgot the second one. Nadira, do you remember the second function?
Uh,
Inadira, can you help Hafiza?
we want to find the instantaneous rate of change. Is it correct, teacher?
Okay, correct. Yes, correct. 5 star for both of you. Okay, so the function of the principle of differentiation is to find the slope of tangent and then to calculate the instantaneous rate of changes at the particular point. Okay, good everyone. I can see that you already understand about our lesson today. So as your homework, you are given a task to solve this question. I hope that you are able to answer it and we will answer on the next class, okay?
Okay,
Okay,
teacher.
teacher.
Okay, good.
Okay, teacher.
Okay, good. Okay, before ending our class, there is an activity for you, which is a simple quiz that will measure your understanding about the concept of this topic. Okay, wait, I will give you the link. So I already sent the link for you in the chat box. Okay. So Discord to join the game, the quiz. Okay, I can see that all of you already joined, right? So let's start
Yes.
our quiz right now. Okay, good. Okay, definition of differentiation. Okay, first question. What is the type of the principle of differentiation that we learn in this lesson today? Okay, I can see that both all of you correct. Okay, good. Next. The second is the graph with curve below is referred by either it is uniform or non-uniform motion, or either is the speed is increased or decreased. Okay, good. Oh,
Teacher
I
tak
can see
sempat.
that. Oh, it's okay, it's okay. But you know the answer, right?
Yes, yes.
Okay, it's okay. At least you know the answer, it will be okay. Okay, next. Okay, true or false? Shell is used to find slope of tangent line. Is it true or false? Okay, all of you get the true answer. Okay, next. Okay. H is interval value for either is changes of okay.
We very fast, teacher.
Okay, good. The best student ever. Okay, the last one. Limit as the interval approaches to zero to make the interval as close as possible to zero. We actually becoming zero. Sorry. So it's quite complete. Wow, okay. You are so intelligent. So let's see our result. The third one is Fatih Chamet. The second is Hafiza. Congrats. And the first is Nadira
Yay!
Cantik. Okay, congrats to all of
Congratulations,
you.
Nadira.
Congrats.
Congrats to Nadira Cantik.
Congrats for all of you. Okay, so that's all for our class today. Thank you for joining this class.